Hi friends, I am Akshay. Today I am going to explain a brief introduction about fluid mechanics from Unit 1. So, fluid mechanics. Fluid mechanics, we deal with the liquids and gases, right? So, let's talk about the matter first. So, what is a matter? Matter exists in three states, that is solids, liquids, gases. In this, solid is different part and liquid gases are different part. Liquid and gases are called as fluids and solids are called as solids. So when coming to matter examples, for example, we take water. Water is in liquid state, in solid state and gaseous state in different conditions, like water in liquid state as we drink, and ice solid state, and vapor gaseous state. This is the about matter. Next, fluid. Let's talk about the fluid. What is a fluid? So fluid is nothing but it is a liquid or a gas. Okay. Next, a substance which is capable of flowing. So fluid is not a solid material that puts on rest, but it can flow continuously. A substance which is capable of flowing. It is capable of flowing with a short amount of force. Okay. It has a no definite shape on its own, but confined or conformed to shape of containing vessel. So fluids doesn't have any shape until we put it on a confined shape or container. Okay, it deforms continuously when subjected to shear stress, no matter how small the shear stress may be. So here you can understand that uh, the fluids are continuously subjected to shear stress. So, as you all know, shear stress is the tangential force acting on the surface of the any substance or a liquid or a fluid, right? So, no matter how small the shear stress may be, if it is a small unit of shear stress, the fluid deform its shape, right? So, next, fluid means continuous deformation under the action of shear force. As we have discussed earlier, continuous deformation, it deforms continuously the action of shear stress. How the shear stress falls on the fluid? Because of, for example, air. So when you observe the water on the sea, you can have a lot of deflections, like right deformation, right, due to air. So these are the shear stresses. Air is acting shear stress on the liquid of seawater, right? So this is a perfect example for that. Next, define fluid mechanics. Fluid mechanics is that the branch of science that deals with behavior of fluids when the fluid is at rest and the fluid is in motion. So, fluid mechanics is nothing but the, the which deals with the, it is a science which deals with the behavior of fluids. Means how the fluid behaves when an applied force is applied on the fluids or removed, or different types of loads acting on it, and when the fluid is at rest and the fluid is in motion. When we apply loads on fluid at rest and when we apply loads on fluid is in motion, or the which when the fluid is in running or flowing in different conditions, we observe it, we calculate the everything of the fluids. This is what about the fluid mechanics. Fluid mechanics is the branch of science that deals with the behavior of fluids. it be we deal with the behavior of fluids when the fluid is at rest and the fluid is in motion. Next, distinguish between solids and fluids. So the main difference between solids and fluids are molecular structure. So when you observe the solids and fluids difference, molecular structure, so in solids, the molecular structure of a solid is very close to it, right? The distance between two molecular limits are very close to it. When you compare to fluids, in fluids you can observe that, for example, it has a larger distances, like it freely moves in that own boundary, right? So next, first is molecular structure, second is relative ability to resist external forces. So as you have known, solid have a more resistance than the fluids, right? So next, this is the distinguish between the short form of distinct differences of solids and fluids. First is molecular structure, second is relative ability to resist external forces. Next, this is the clear example what I was going to say previous. So solid distinguish between solids and fluids. So here you can observe the solids, that is force of attraction is more. That means where the solid molecule, the molecules are close to each other, so the force of attraction, that means if a solid takes a force, it continuously shares with the other molecules of it, right, in a very speed manner. When compared to liquid, here the force is the spacing is more, the molecular spacing is more. So when you apply some load, it takes some time to compress it or do something in it. Like when compared to gases, so gases have a large distances, large spacing in molecules. Next, molecule. This is the molecular arrangement in a solid, liquid, and gases. Next, given it contain large number of molecules, right? So little amount and rigid structure. So more large number of molecules are rigid structures. Next, ability to resist force. All three are applied forces, that is can see can be applied. For solid, tensile is applied, compressive is applied, shear is also applied, right? Tensile means pulling in opposite directions, compression means pushing in opposite directions, shear means tangential forces, right? Next, this is about solids. It can apply any load, you can apply any load on it, solid object. When compared to fluid, fluid has no tensile strength. It doesn't have any tensile strength. You can't stretch it, right? Next, can resist compressive force when keep it in container. So when you keep the fluid in container, you can it can resist the compressive forces when you put on pulling on it, right? Not the pulling, sorry, pushing on it. It can resist it. Okay, next, inability to resist shear stress gives them characteristics of flow. As you have discussed earlier, when the shear force is acting on the fluid, it deforms. That means when the shear force is acted on it, it starts flowing on the floor, not the floor, but the substance is on that, right? So next. So this is about continuum. What is continuum? Let's learn about it. In spite of large mobility and space spacing of molecules of fluid for mechanical analysis, fluid is considered to be continuum. It means continuous distribution of molecules with no voids or empty space. Justification. Fluids involved in most of engineering applications of large number of molecules. So here you can see that continuous distribution of molecules with no voids or empty space. Here we are assuming the fluids are as continuum fluids, because when we are testing something, we can't take it as it has a voids or empty spaces, and we can only assume that it has a completely filled with the molecules, so that we can analyze the every situation of a flowing liquid or a rest in a fluid, right? Next, let us see next one. So Knudsen number, degree of departure from continuum, right? This we call it as a Knudsen number. That means mean free path by characteristic length of flow. Role of shear stress or shear resistance. So first, what is the role of a shear stress in fluids when it is rest and in motion? First, let's talk about the rest. When fluid is at rest, the shear stress is zero, because when the fluid is at rest, it doesn't undergoes under a shear force. I mean shear force, but shear stress. How the shear stress formed in the fluid or a liquid? I mean fluid, because of its different layers. When the shear force is acted on a free liquid, it has some layers, and those layers can act as a different shear stresses, right? So when fluid is in motion, shear resistance exists between adjacent layers of fluid. So as I have said now, shear, this is about the a small, this is a small introduction about fluid mechanics of unit 1. So let us go deep through another video. So thank you everyone.